Roller coasters are fun, but how do they work? Like right here. Why doesn't the whole car just fall off the track? It's upside down! The answer is centripetal force. Okay, but what is that?
According to the dictionary, centripetal force is a force that acts on a body moving in a circular path. Okay, never mind. We'll just show you.
Okay, hold up. What even is a force?
A force is just any push or pull on an object, but doesn't actually need to be touching anything, like gravity, for example. Alrighty then, now to the tricky part. What is a centripetal force? Here we have a jar of Capri Sun, perfectly happy, not speeding up or slowing down in any direction. We call this unaccelerated, because the jar isn't accelerating in any direction. As the car starts to turn, the center console pushes on the jar, causing it to accelerate. Important note, the jar is moving at the same speed, but is still accelerating. This may sound confusing, but don't worry, we didn't break science. Speed is all about the numbers. When you're driving, you might notice speed limit signs that say 25 or 50 miles an hour, but they don't tell you which direction you're going. Now if we add direction, we get velocity. This describes your speed in the direction you're going. Acceleration is what happens when your velocity changes. So if you speed up, slow down, or even if you're turning, you're accelerating because your direction is changing.
Okay, but what does that even have to do with the jar?
We can see that the jar is accelerating because we can see how the water sloshes around inside. For something to accelerate, there has to be a force on it. So we know a force must be accelerating the jar. This is the centripetal force. You know what else is fun? Rockets. Here we have a satellite in space.
Hey, why doesn't it fall straight down?
Easy. It's moving super fast, like a bajillion miles an hour fast.
Well, if it's moving so fast, why doesn't it just zoom off into space?
This is where centripetal force comes in again. If we plop down any forces acting on a satellite, we get just one. Gravity is the only force acting on the satellite. Even though the satellite is moving around the planet, the centripetal force of gravity is enough to keep it from flying away. The important thing is that at any given time, the direction of the force is 90 degrees from the direction in which the satellite is traveling. So gravity is always pulling the satellite straight towards the center of Earth. Now, back to our cup of water from before. If we swing it around upside down, we should start to see our centripetal force. As I begin to spin the cup up and over my body, oops, the water fell out.
Ryan, the water was supposed to stay in the cup.
The water fell out because it wasn't spinning fast enough. This shows that for centripetal force to work, you have to be going fast. Now, if we swing the cup faster, it goes all the way around with no spills at all. The centripetal force on the cup from my arm keeps the cup moving around in the circle and makes the water stay in the base of the cup. Now, we can see why roller coasters work. So now we know that the roller coaster is going fast enough that it stays in the centripetal force of the track instead of just flying off. And the centripetal force is what keeps it moving around the loop. Engineers take advantage of centripetal force all the time. And now that you know how it works, what would you make using centripetal force?
If you're interested in other concepts involved in designing roller coasters or in becoming an engineer someday, check out our other videos here on Roundabout Productions.